Hello friends, welcome once again to my channel. Today I'm going to discuss the topic which is homogeneous differential equations. If this is your first time of viewing, kindly consider subscribing to my channel so that you'll be notified each time I upload a new video. Now, homogeneous equation or homogeneous differential equation came to existence as a result of the fact that some differential equations are not variable separable. There are some differential equations in which you cannot separate the variables, and because of that, another means is utilized in solving such differential equation, and that is how we can embark on the usage of homogeneous equations. Okay, now when do you say that a differential equation is homogeneous? It is homogeneous whenever the degrees of the variables are equivalent to each other. None is greater than the other. For example, now if you take a look at this, you will see that the degree of x and the y here are 2. That is degree 2. The power is 2. Coming down here, don't think that this is a degree 1 because you are seeing x and seeing y. This means that x is multiplying y, which means that the degree is 2. Because had it been it is x times x, for instance, that gives us x squared to tell us that the degree of this differential equation is 2. So they are uniform, hence it is a homogeneous equation of degree 2. Sometimes the degree can be 1, it can be 3, etc. Okay, so whenever you see that the degrees are the same thing, you know that it is a differential equation. In differential equations, we normally make the substitution uh, y equal to vx, because this is the only thing we can do to make sure that this particular differential equation becomes variable separable. That is to have x terms or x factors and y factors in different sides. Okay, so we normally say let y be equal to vx, which means v is equal to y all over x at the end of the day. So if y is equal to vx, then v is equal to y over x. That is making v the subject of the formula. Now let us utilize this in solving this given differential equation of degree 2 and see what we are going to get. Okay, so now we shall say let y be equal to vx. Now this is now a product. Therefore, you can use product rule of differentiation to differentiate this. So if y is equal to vx, our dy over the x, if you know product rule of differentiation very well, go to my playlist of YouTube playlist of the calculus. You will see product rule if you are not familiar with it, so that you can learn it also. So the y over the x means you get v, keep v constant, then differentiate x. If I differentiate x, I will get 1 plus, this time around I'll keep x constant and differentiate v. If I differentiate v, I will get 1. That is, but because I'm not differentiating with respect to v, I'll attach the v dx. So to differentiate v, I will get 1 dv dx. And of course, this one is nothing, because when I multiply the v dx by 1, I'll still get the v dx. So dy over dx is now v times 1 is v plus x dv all over dx. So I've now seen that my dy dx is now v plus x dv dx. I will now use this value here to replace dy dx here, because this is now the value of dy dx. Hence, I can now write that v plus x dv all over dx equals x squared plus y squared all over xy. Now already we've known that y is equal to vx, so anywhere I see y, I will just put in vx. Come over here, I will have this as v plus x dv over dx equals, now my y is vx, so I'll put in vx for y here. So I'll now have x squared plus vx squared all over x. Look at y again, I'll put vx dot vx. So this gives me v plus x dv over dx equals x squared plus v squared x squared all over x squared v, because x times x is x squared. So I can write this as x plus v plus x dv dx equals So I will now separate as x squared over x squared v plus v squared x squared over x squared v, separating them one after the other, so that x squared will cancel x squared. We are left with 1 here. X squared cancel x squared, v cancel out, we are left with just v. Hence, we shall have v plus x dv over dx equals 1 over v plus v. I can call it v over 1. So I will simplify the right hand side. I will now have that v plus x dv dx equals, the LCM of v and 1 is just v. V divided v is 1. 1 times 1 is 1 plus 1 divided by v is v. V times v is v squared. Okay, now we shall bring this v to the right hand side, but before that I need to erase this particular side so that we can continue. Okay, so from here, this v comes over, we'll have x dv over dx equals 1 plus v squared all over v, then minus v, because this is positive crossing over is now negative. This can be v over 1. The LCM is v. V divided v is 1. 1 times this gives us the same thing, 1 plus v squared, minus 1 divided v is v, and v times v is v squared. Remember, x dv dx equals this. Now from here, v squared minus v squared is 0. So we are left with x dv over dx equals 1 all over v. Now, I want to say, because this is yet to be separated, we've not separated the x and v variables properly. But to do that, I need this v to be in terms of the v here, so that this x comes to this side. And for this x to come to this side, I will divide both sides by x. Okay, and for this v to come to this side, I will multiply both sides by v. So hence, I can say multiply both sides by v over x. This is the only thing I will do in order to ensure that x comes to this side while v comes to the other side. So I will multiply both sides by v over x, because whatever you do to both sides of an equation, it remains unchanged. So I'll have v over x multiplying x dv dx equals v over x multiplying 1 over v. So that v cancels out, then x cancels out. So we have v dv dx equals 1 over x. Then we now integrate both sides with respect to x, and that will give us the required answer. So I'll wipe. Okay, so from here I'll integrate both sides with respect to x. So this is integral of v dv dx equals integral of 1 over x dx. The x cancels the x, so have integral of v dv is now okay equals integral of 1 over x dx. Okay, so if I integrate v, I'll have v power of 1 plus 1 over 1 plus 1 equals, if I integrate 1 over x, I'll get natural logarithm of x, then plus c. So this is now v squared all over 2 equals natural logarithm of x plus c. Okay, now, but in the beginning, we said that y is equal to vx, okay, which means v is just y all over x. That's the value of v. So I'll substitute it here. I'll have, this is something I'm saying 1 over 2 into v squared. And my v squared is just y over x all squared equals ln x plus c. So this is something as half y squared over x squared equals ln x plus c. So finally, this can be written as y squared all over x all over 2x squared, because these two will multiply x, equals ln x plus c. Cross multiply, I will now have that y squared equals 2x squared ln x plus c.